Hello there and welcome to a video on Casual CNC. I am VB and today I would like to show you the second iteration of my experimental cross-cantilever 3D printer. The proof of concept turned out to work much better than expected, so I redesigned the weakest parts and added a few more to improve on stiffness. Let's have a closer look from the beginning. Old base was just a square piece of plywood with some printed parts attached, and it was bending a lot. My basic limitation is size of 22 by 22 centimeters, which my Creality K1C can print, but even at this size it has hard time putting the first layer properly due to the thermal bending of Hotbed. All new parts have been printed in PETG-CF, which hides small defects well, so new base came out nicely. It accommodates power supply, controller board and motors. Stiffness has been further improved by adding third rail on the vertical axis, using extra bridges within the base and by attaching rails directly to the motors. I'm well aware that the design of this printer has got some intrinsic problems, and it won't be the fastest one or the cheapest one ever. But overall, it is very simple to build, it looks nice when placed on desk, and print quality exceeded my expectations by far. These are just basic budget models of MGN12H rails and NEMA 17 steppers. I'm not building this printer to save money, just the parts alone will probably cost you more than some good printers which are fully assembled and readily available. The single most expensive part is the Manta M5P controller board from Big3Tech with CB1 compute model and TMC 2209 stepper drivers. I've upgraded from Arduino Mega board with RAMs version 1.6 to be able to run Clipper easily and have a 24-volt system. I've struggled to find a suiting power supply, as the typical ones used for 3D printers won't fit into my base. Luckily, there are some power supplies of different form factor which are labeled as LED power supplies, but are actually just normal constant voltage ones. The one I've ordered is rated 300 watt and it turned out to be nearly 2 centimeters longer than specified. Just to be on the safe side, I chose the cables which are somewhat oversized as well, and then I had a hard time fitting everything together. There is just a single fan installed to cool the base at the moment, and this turns out to be insufficient. When printer runs for several hours straight, the CPU of compute model reaches the range of 85 degrees Celsius. It still runs without any problems, but would wear out electronics in the long run. I haven't measured temperature of other parts, but at least PETG-CF does not deform. CB1 compute model from Big3Tech comes with Wi-Fi antenna included, and I chose to have no Ethernet nor display connected for the moment. Once configured, it is absolutely sufficient for me to have web browser and slicer accessing the printer over Wi-Fi. Recently, I have discovered to myself that printing parts vertically rather than flat often leads to a better result. This is the fourth version of XY axis connector, and overall I'm very happy with the result. There are just a few small print defects which can be optimized next time. The first iteration of the printer reached maximum speed of around 400 mm per second before skipping the steps on XY axis. This one does 800 mm per second easily, and I haven't even tested the limit. Rated current for steppers is 1.5 ampere, but they are configured to 0.6 in Clipper and get just slightly warm when running. The bridge on the top serves multiple purposes. First, it holds idler pulleys for the Z-axis bolts. The pulleys are just screwed with a single M3 screw which goes directly into the plastic. Second, it adds lots of stability to the whole system and can be used as a handle to carry it. Third, it holds extruder with cables. Moving printer parts contain holes with teeth matching the GT2 profile of the belts. They are connected with a wedge, and I had not a single failure so far. Getting the proper tension is not quite easy, however, and there is no way to fine-tune it. The print head definitely needs some attention, but I haven't changed anything on it since the first version. It contains a V6 Hotend, an inductive proximity sensor, and a single blower fan which serves as a hotend and a part cooler at once. There were no problems with jamming, but the cooling of the part is insufficient in many cases. I consider redoing it completely and would appreciate any advice you may have on which kind of hotend should I go with. Direct extruder is out of reach for this design, I assume. And no, printhead cannot fly away if you are not careful with your G-code. 3D printing allows to iterate on design fast and cheap, and I had to redesign the bridge multiple times. The version visible here is not the final one. It turned out that the thickness of the bridge does not suit the extruder, which I noticed just when trying to print. The plywood board from the prototype was repurposed as a hotbed adapter, which also serves as a thermal insulator. The pattern should minimize thermal bending. I've printed at 70 degrees Celsius for around 10 hours, and it served very well so far. Initially, I planned to use an energy chain, but this minimalistic cable management requires less space and does its job as well. TMC 2209 stepper drivers allow to use sensorless homing on X and Y axis, and it works at 20 mm per second reliably. Bed leveling was easy to set up in Clipper, using inductive sensor, and it works reliably as well. With a minor adjustment, bed is quite flat, with variation of just around half of millimeter, and it stays consistent. I automatically level it on each print. The print area has increased to a square of 184 millimeters. Nevertheless, Clipper gets first layer better than I was able to get with 145 mm on Marlin. But this may as well be due to the improved mechanics. To see how printer performs at high levels on Z-axis, I've printed a vase which is 17 centimeters tall and took around 5.5 hours to print. The printer is indeed quiet, just the part cooling is loud and needs to be improved anyway. During that 25 hours of operation, it had not a single glitch. At the moment, input shaping is not configured and the vase has quite prominent ringing visible. Going from down to top, ringing pattern changes slightly, but seems to remain on the same frequency. Initially I was quite pessimistic if input shaping can help with this design, but my first tests look very promising. Thank you for watching and hope to see you next time.